So I represent DLP technology in the Indian market. I work for Texas Instruments. Texas Instruments is a semiconductor manufacturer, design, innovation, that's what we go behind. So we are not an end product manufacturer, we are a component manufacturer which goes into projectors which gets used in classrooms, and that's what I'm going to talk about. I'm going to focus on the last line actually, how large displays engage in student engagement in a classroom. My talk is going to be a little tactical. It's going to be from the experience I've had engaging with the Indian school industry for almost a decade. I think I have more questions than answers at the end of this decade, and I think you will realize that as I go ahead in this 10-minute talk. Very quick introduction on DLP technology. It's an optical semiconductor device which gets used in projectors. It consists of millions of tiny mirrors which move to form an image. And for example, the projector which you're seeing is possibly using a DLP chip. The image is formed in a microdisplay fashion, and using optics and light, it's magnified to form a larger image. A predominant usage of projectors, almost 50% of projectors worldwide get consumed in the classroom space, and that's one of the reasons Texas Instruments, although we are not an end product manufacturer, we are engaged with the education industry. A very quick slide on some of the benefits, because of which almost 50% of the projectors which are built worldwide use DLP technology. And the second and the third items are what relates to education segment when it comes to reduced total cost of ownership, which is very important in an Indian environment where you're talking about schools which don't have air conditioning, which have dust, etc. I'm not going to talk about details about the various benefits. So I'm not here to talk again about DLPs and projectors, etc. What I would like to talk about, and then during the discussion, listen and hear from you, is what we have done now so far and where to take it forward. What has happened in the recent 10 years is deployments in the smart class format, where primarily in the urban and the semi-urban centers, you have multimedia teaching being conducted through large format displays, computers, interactive displays. And I think the number of these classrooms is probably around 200,000, predominantly in private classrooms. And some select 3D stereoscopic classrooms are also available today. We also have IT labs which are there in urban and semi-urban centers, and quite a few in government schools, which are typically one lab per school. And you're talking about secondary schools, and probably the number is around 100,000 government and private schools. I have put a question mark around these numbers because today there is lack of independent market research out of India to actually say how many schools and how many classrooms have some form of technology deployed. And in fact, that's one request to the organizers and people who run digital learning to see if they can actually be one of those people who can bring about an independent research on how much actually gets deployed and how it gets utilized. And these labs are predominantly for computer-based learning and projects. Why did I say this? This is an interesting slide which is from Future Source, which talks about the total classroom count worldwide compared with what is available in India. And this is probably 4 years old. And interestingly, India has the largest number of classrooms, much more than China. And when we talk about, this slide is actually about penetration of interactive displays into classrooms. And we were number one there, but we are towards the end in this particular slide. This is a 2011 slide, again from Future Source. I wish there's one from India, which talks about approximately a 1% penetration of interactive displays in Indian classrooms, and it's expected to go to 10% by in another 3 years. Whereas if you look at some of the countries which are highlighted like Mexico, Russia, China, they are looking at a far greater adoption, and I wonder what is it that we're missing which some of these other countries are adopting at a faster pace. That's part of the questions which are there in my mind, and is it something India has to adopt something different? If so, what? And these conferences, are they going to help us arrive at some of those solutions? And if India needs something unique, for example, I just put some key challenges. Power is a big challenge. Today we have display projectors which actually work on very low wattage and which can run on a 90-watt solar panel. Our classrooms are predominantly ventilated through windows, which means that you cannot put curtains, which means ambient light is going to be high. And today we have displays which can actually work with a good ambient light and still produce an engaging image, which is very important for the student to be engaged in a classroom, especially when it's still teacher-led, but when a multimedia content is being thrown, you don't want the student to doze off or get distracted. Indian classrooms and schools are very, very dust prone, as you can see in the bottom picture, and we need technology which can work in dusty environments. Temperatures are more than the Western European and the North American countries, and on top of that, we don't have any air-conditioned classrooms. Even the private classrooms are typically non-air conditioned. So we are working to, as a technology provider, we are working with our ecosystem to ensure that some of these care-abouts are captured in some of our next generation products. But as an industry, it would be good if there is a broader consensus on what type of technology gets deployed and kind of a quantum of these deployments which can actually help us deploy more R&D budget to come up with unique solutions. I'm going to talk a little about 3D stereoscopy in classrooms and share a little experience we have had doing some study in Western Europe. Okay, just to differentiate 3D animation and 3D stereoscopy, I'm talking about the one where you use glasses. You would have all watched movies, some form of a 3D movie in a theater, and today you have this technology available in classrooms too. We did a study in Western Europe 2 years ago, and it was a well-researched one. Almost 15 schools were covered in 7 countries. And one of the reasons we felt was 3D is going to be more engaging, 3D stereoscopy I'm talking about, is going to be more engaging because we know that students prefer the visual medium of learning than hearing. And that exactly was the result. The results were students who studied in 3D, so these classes were segregated and they were taught in 3D and they were taught in 2D, and 86% improvement in those students who studied 3D and only 52% in those who studied 2D, and almost a 92% attention with those students who studied in 3D. All these studies are available in dlp.com/3D. You're free to actually have a look at it. There are more case studies, and I hope to do one on India very soon. And we do have some classrooms in India, I think probably 200 of these, which use 3D for labs. I think I'm going to skip some of these slides. Just to summarize that almost wherever we have asked questions, it's about people feel 3D stereoscopic learning has had a better impact on their learning. Students, teachers feel the same, and in fact even parents have a better feeling about their kids studying on 3D. And in terms of the ecosystem for 3D, we do have all the DLP projectors which are available today in the market, the ones which start from 15,000 rupees onwards also, they are 3D ready. So today you can actually buy a projector which is 3D ready, and once you have the 3D content and the 3D glasses, you can fit out your entire classroom for 3D. To summarize,
please conclude.
Sure. Our technology has primarily, in the last 2 years, 3 years, has been driven around education. In terms of new innovations, what we are coming out with. We are talking about solid state illumination, which talks about no lamp to be replaced, which is a great fit when it comes to rural deployments. We are talking about 3D, which is going to be default in all the projectors. We are including interactivity in almost all projectors, which will improve engagement, teacher-student engagement. And we are working on optics, which are going to make the visual experience more engaging for the students.